Okay, so let's try question 5. 5 reads as follows. You need to make a password. Every player must have a password that has 2 capital letters followed by 3 digits. Capital, right, it just narrows it down to 26. For each of the following conditions below, determine the probability that a password chosen at random will contain letters S and Q, right? So this is basically setting up your universal, by the way. A, if repetitions are not allowed, and B, if repetitions were to be allowed. Okay, so we're going to consider both cases there. So let's figure this out. So remember, all passwords that we are considering here have S and Q in it. So S and Q must, right? That's just a fact. Those are the ones we're considering here. So for A, P would be NU and A. What is the U? In this case, all possible, let's see. So if the condition, the overall condition, like if my universal will only be considering, so let's say if the website does not allow repetition, right? It just can't, it will just send an error. That's not even an option. So my universal has to take into account in this case that there are no repetitions. Okay, that's the way the question is worded. So basically you would consider 26 times 25, those 2 letters, and then 10, 9, 8. That's 26, pick 2 times 10, pick 3. That would be the pool that I'm drawing from. Okay, and NA, I'm restricted to S and Q, right? So my 2 letters and then my 3 numbers. So the problem is you could have SQ here, you could have SQ there, right? It's as long as it's in the password. So you have 2 options first, then you have another one second because you can't repeat. And then you would go with the numbers 10, 9, 8, like that. So it's 2, basically, it's 2, sorry, why is it 10 there? 2 times 10, pick 3. Okay, that's what's happening on the top. So here's my probability. 10 pick 3, 720. And then 26 pick 2 times 720 basically is 468,000. Oh, sorry, I got the top wrong. I think I forgot to multiply by 2. Right? This is 720, so times 2 yet. So that's 1440 over 468,000. And there it is, 0.00308 and something like it keeps going, right? But there we go. That's A. If repetition is allowed, then it's going to be slightly different. My probability will be for the NA part, maybe we'll do NA like this, NU like this. Everything changes, okay? Because now you can go 26 times 26. If that's allowed, then it's 10 times 10 times 10. So that's 26 squared times 10 cubed. That's the universal, right? I'm allowed to have repeats, so that you're considering everything. For NA, let's see here. SQ, SQ. So in this case, we have 2 times 2, right? We can consider both of them. And we have 10, 10, 10. Right? So this is 2 squared times 10 cubed. in a sense. And you know what? I don't want to edit this part out. I'm looking at this. If I go 2 times 2, this is assuming that I could have doubles, right? Like S and S. But the question says it has to have S and Q in it. So if I picked S, right, I can't have it again. So I have to therefore go 2 times 1. Like that. So it's just 2 times 10 to the power of 3. That's what it is. Yeah, I was just reading that. So probability is 2 times 10 to the power 3 over 26 squared times 10 cubed. And so that's 2,000 over 676,000. Okay. And that is 0.00296 there for that. You don't have to go that far. 4 decimals would have been good, but it doesn't hurt. So those are the two for A and B under no repetition and repetition allowed. And the key here was the S and Q. The question says has to have both, not or. If it had said or, then it had to have either S or Q, and then you would have been able to go 2 times 2. Well, no repetition here, so 2, 1 still, but here it's 2 times 1 again because it has to have both. Okay, so that's for 5. Let's keep going. 6. What does it read? How does it read? Let's see here. This is not rehearsed. I don't have a key in front of me, so I'm just going on the fly. I hope it helps you. High school athletics form a beginning curling team. So there's the teams again. 9 students, including you and your 3 friends, have signed up for 4 positions of skip, third, second, and lead. So notice how it gives specific positions. The positions will be filled randomly, so every student has an equal chance of being chosen. So that's obviously that has to be stated. Even if it's not, we're implying it, or else this is biased. This doesn't work. A, determine the probability that you and your 3 friends will be chosen. Okay. So let's see here. Let's see if we can narrow it down. We have specific positions that you and your 3 friends will be chosen. It doesn't ask how many ways can those 4 positions be filled. It just says how many ways can you be chosen. So I feel this is a little unfair for a test question, but I think it's definitely okay for a homework question. So here is 6. So A, determine the probability that you and your 3 friends will be chosen. Let's see. So here we go. 6. Let's answer that. So we'll say probability of being chosen, NA, and U. Okay. And U will be from the, it says there are 9. So it would be 9, choose 4. Okay. And A, it's just your friends for those 4 positions. So it's you and your 3 friends. Okay, so from the 4, we want to choose just the 4, right? And in a sense, from the remaining 5, we're going to choose 0, which is just 1. Okay, so always remember that part. And so really 4 choose 4 is just 1. 9 choose 4, I'll quickly calculate that. 9 choose 4, that's 126. If you divide that, that's 0.0079 and so forth. you will notice that this one, actually, if I think about it, because you're stating a probability, you could have used permutations here. Because of the 4 positions, you could have probably be led to believe you have to use permutations, and you would actually get the same final answer because you're stating probability. And here is why. Technically, when you use permutations, when you're supposed to use combinations, you're double counting because order matters. And it ends up being that if you use perms up top and at the bottom, those repeated arrangements that you've counted cancel out. Okay, that's why when you do probability, quite often you get the same final answer as somebody that used combinations. You will not be marked wrong in that case. But if I only asked you how many ways can you choose a team of 4, not a probability, then it does matter. Okay, so keep that in mind. So this is A, 6A. I think I'll just have time to do 6B and then we'll wrap it up here. How would this change if only 8 students had signed up for the team? Okay, so my NA, you would go 4 choose 4, assuming your friends are still there. And that means that from the 4 remaining, you choose 0. And this would be 8 choose 4 instead of 9 choose 4. So this is still 1 over. Let's find out what 8 choose 4 is. That's 70. Okay. So that would be 0.0143 as that. And I'm going to stop there. I hope this helped you. Any questions, come and see me anytime.